All right. Integrating inverse trig functions is recognizing that if I've got one of the rules, how to apply it working backwards. So I've got the integration of dx 1 minus 4x squared. Now if I had a perfect little 2 up there, it would be sine to the minus 1 2x, putting things in their place, given that the rule of sine to the minus 1x is 1 on root 1 minus x squared when I differentiate. But I've got the 2 here, so I have to have it on the top for it to work. I don't have it on the top, so what has happened is they have halved it, plus c. Down the bottom, exactly the same thing, except I've got to put in boundaries. Integrate root 1 on root 1 minus y squared. I'm looking at my rules. I'm seeing that that's sine. There's nothing I have to change, so I'm happy. I just get to write sine to the minus 1y, half and 0. I need to sub that into my calculator, and I need it to be in radians. So I'll get 30 degrees and I'll get 0 degrees. 30 minus 0 is 30, but that's pi on 6. Find the area bounded by the curve. I do not care what that looks like. I do not know what that looks like, but I know that it's bounded between x is 0 and x is 3, so I've got to differentiate dx. I write it out and I look at it, I think, that's sine. And then I substitute them in. They're not all sine, by the way. I'm sorry that I've used all sine, but they substitute them in. And because this is 25 according to the rule, that's got to be 5 on the bottom, and then I substitute it in. Sine to the minus 1, 3 on 5, minus sine to the 0, and I get just 2 significant figures, 0.64. Okay, the area bounded by the curve and the x-axis and the line, x is minus 2 and 2, is rotated about the x-axis. So straight away, volume